Hello and welcome to Programming Rush. Today in this video, we are going to solve the problem binary tree cameras. So this problem says we are given a root of binary tree. We need to install the cameras on the tree nodes where each camera at a node can monitor its parent, itself and its immediate children. That means we have a node here, okay, like this. We have a tree like this, okay, and if we install a camera here, then it can monitor this one, this one, this one and itself, because it says that we can monitor the parent, its immediate children. These are the immediate children. Immediate children means the next nodes, and it itself. And so in this program or in this problem, we need to minimize the number of cameras needed, okay. So in this, the very short example, as we can see that the minimum number of cameras is equals to 1. But let's see the examples given in this problem. The first example that we can see here is the same example that I have drawn. Here we can see the node has a child. This node has two childs, not one, and a parent, and it's itself. Now installing a camera here covers all the three nodes, and so one camera can do all the 1, 2, 3, 4 nodes, so the output will be 1. Similarly here we can see that this camera can watch here, and also this camera can watch here. So it is the most optimum answer that we can find for this tree, so and for these nodes. So this is the only options that we are left with. Installing a camera here or here won't work, because in any ways a node will be left and we would require 3 nodes, but that is not required. We can do it only with 2 nodes, okay. So these are the very simple examples that we can see, and from these examples only we can think that how to solve this problem. And so let us move to the approach part. In the approach, first of all, we are going to see how this works, and finally we are going to come in a more optimal or a more structured way of algorithm. So first of all, let us draw a tree. Okay, we have drawn a tree and we need to count the number of cameras, okay. So let us create a variable here, cameras, initially to 0. Now what we can do, we can first, let's check this node. So this node does not come in a camera, but this is a top node. We can see the further nodes. If there are no further nodes, we can say that we require only 1 camera, or else what we can do, we can say that the camera can be installed here or here, because from common sense we can say that if this nodes, we can always leave the first node from either side, from this side, from the bottom or from the top, okay. We can leave both the nodes and come up to the next part of nodes. So from the root node we are going to come into children node and check here if there are any nodes. Yes, there are nodes, and for both of them we need to put cameras, because we cannot do from here to here. This is not possible. So here we need to install a camera. So I'm marking it as C, and here also C, okay. And then what we are coming down again. For that we do not require to come down, but here we are coming. So coming here we can see that the parent node has cameras, so we don't require to install any cameras. And finally for this camera and for this camera, for both of them we can increment the values of this cameras variable, giving the answer as 2. So the final answer for this problem is coming to 2. But what will happen if this node has another child like this? Let me draw in yellow only. Okay, this node has another child. Now what will happen? So we can see that there is no optimum way of reducing to 2, but we need to do it to 3. And so installing a camera here or here, anyways it is similar or same thing, okay. So the answer will be for here will be +1, that is equals to 3. So what we can do by going from top to bottom, this is implementation of this part will be little bit trickier because we need to check that the top has a node or not. Instead, what we can do, we can move from bottom to top. Okay, so this is a very simple approach that we are going to follow. So first of all, we have this, and from moving from the top of each node, okay, from moving top, we are going to say that first of all, what we're going to do, we are going to move from root. We are going to not move to root from root to leaf, rather we are going to move from leaf to root. Okay, and we're going to ask the root leaf nodes that, or the child nodes that, are you covered? We will have 3 questions. Are you covered in, are you in camera range? This is a basic question. Are you in camera range? A camera range exists for up to 3 nodes. So are you in camera range? Yes, I am in a camera range. Then also it asks 2 questions. Do you have camera? Do you have camera or no camera? Okay, so this is a 2 question. For example, let's say here we have another node, and here it is a child node, again 2 child nodes, and this should have a camera. Okay, so this node asks this node that, are you in camera range? So it says yes, I am in camera range, but this does not have any camera, so it answered this question. Okay, this is the question 1, and these are the sub questions. And other thing is, you are not in camera. So if you are not in camera, then this node should have a camera because this is a camera. You are not in camera. Okay, so what is the question like? Let us say again by drawing. Yes, this node asks this node that, are you in camera? It says no, I am not in camera. So this node makes it like, yeah, I know you need to install the camera. So what we do, we can do like this. It should be installed like camera like this. Okay, because this node is going to add both left and right. It is going to ask both. Okay, so this node, for this example, we are saying that this node asking this node. Okay, let us mark 1, 2, 3, 4, 5, 6, 7, 8, 9. So the node 5 is asking the node 7 that, do you have any camera? It says no, I don't have any camera. So what it does it does that it installs the camera here, increment the count, and here is also count, so let me mark it here also. So these nodes have camera, and move to the top part. Now this node asks that, do you have any camera? This node says no, but I am camera range, and this said yes, I am camera range, but and also I have a camera. So this node does not makes itself a camera, rather it moves to the top part. And this node asks this and this, do you have any camera? It says no, I don't have any camera. It says yes, I'm in camera, but I don't have any camera. And also the node 3 is not in camera range. So what it does, the node 1 should requires a camera. So finally the node 1 installs a camera in itself. So rather than these words, we are going to use a numerical values to tell this, but the conditions are going to remain same. Are you in camera range? So for that, does have camera, no camera. In camera range, camera, no camera, and then not in camera range. It does not have any sub questions. Okay, moving to now an implementation part. Okay, so I think you have understood that the nodes, we are going to move from leaf to root, not root to leaf, from leaf to root, and asking the children, does you have any camera? Are you in camera range? Are you not in camera range? So first question is, are you in camera range or not? Because then only the question arises that you have a camera or does not have a camera. And a camera covers the parent, its siblings, means itself and its children. So parent, children and itself. Now the approach that we're going to follow, we're going to first ask, let me say first one thing, that this node is last node or the leaf node, the childs are null. Okay, this is an important thing. Now first of all we are going to create a function, let's say anything DFS, because it's a depth first search. In the DFS we're going to ask, there will be a node variable. The node variable, we're going to check if it is null or not. If null, what we're going to do, we're going to return a value, and the values are in this scheme, that if there is a 1, that if the value is 1, then we're going to say that camera installed. That means the camera, it is in camera range. Then it will be saying 0, not in camera range. Okay, then the value 2 will say, I should do it serially, but anyways, the 2 will say that I am not in camera range and does not have any camera. So I am writing in way, means I am not in camera range, but I am in camera range but does not have any camera. In camera range, no camera. Okay, so if the node is null, we can think that this node comes in a camera range, because it is a like default value. Because if in null, it is monitored or not monitored, it is a null. So what we can say, it is in camera range and does not have any camera. It is think that nulls cannot have any camera, so we are going to return 2. Okay, then what we are going to do, we are going to check left node and the right node. Okay, and the left node will ask the left, means node will ask the left child, are you in camera range? Okay, and if it is the value of zeros, okay, if it is a 0, any one of them is 0, then this node, the node should have a camera, and then it is going to return 1, that it has a camera installed. Otherwise if the left or right have camera installed, any of them has camera installed, then we do not require to install camera anymore, because it is in camera range. So what we're going to do, we're going to return 2. Okay, if the node, any node left or right has a camera, we're going to return 2. If the nodes does not have any camera, any node does not have are in camera range 0, then we're going to return 1, because we need a camera. Also in this section, if it is a 0, then we're going to increment cameras will be ++, and if it is a null node, then it is a camera range but does not have any camera. So it is a very small function, but this will give us a value that is an optimal one. And now if there is a single node, it will be the main function there. If there is a single node or no node, it is a null, or single node. So it is on a single node, then the value will be as 1, or else it will be a value of 0. Okay, and rest, otherwise the nodes will have an optimal value that will be stored in this cameras variable. So this is our approach for this problem, and let us implement this code. So we are at our code editor, and now let's implement the algorithm from binary tree cameras. Okay, so first of all we are going to create our DFX function, DFS, and it is going to take the tree node, and it will be the node, and the first condition that we are going to check is that the node is null or not, because otherwise we can't work on it. The node is null, that means we have the state that return 2, because it is covered in the range, we can expect that, but it does not have any cameras. Then we will have two variables left. This will be for the left child, okay, and we're going to check that the left child, what is the state of the left child. So node dot left, and we are going to ask also the right child its state by calling that node dot right, okay. And now we are going to check if that left is left is covered in camera or not, or the right is covered in camera or not. If both does not, if any of them does not have the cameras or also are not in camera range, then we need to have a, first of all we need to have a cams variable that is initialized to 0, and we will increment this cams to 1, means increment the cams by 1 because there is a camera required. I want to return from this function 1 because we have installed a camera in this node. Or else what we are going to do, we are going to check, we are going to return, what we are going to return, we are going to first of all check that left is equals to 2 or not. That means that the node is covered with the camera range but does not have any camera. If left is covered with, the left has a camera or not, and also the right has a camera or not. Okay, so if they have a camera, we want to check that. If they have camera, then we want to return, what we want to return, we do not require, so we want to return 2, that they are covered, this node is covered in camera range. But if they are not in, does not have any camera, then the top node will require a camera. For that purpose we need to return this 0, okay. So this is a function, and from the main function what we're going to do, we're going to return DFS of node. But for that we need to check that is it less than 1, because maybe that it has a value single node, then for that purpose we need to return 1, otherwise it will be returned 0 plus cams, because it may be that the null node is passed. It is possible that null is passed. Node number of nodes is 1, but for safety purpose. So we're going to run the test cases. Okay, so I need to do like question mark. It is less than 1 or not. Yeah, so let's check it. It should be root. I don't think there is any other mistake. Yeah, so this is the test case run. Now let us submit this problem, the solution. And yeah, this is 83% faster, memory usage is 55%. I'm getting different values at different times, but anyways the solution is accepted, and it is a very small code for this problem. What this problem is binary tree cameras, and it is a hard level of problem, but we have covered this problem very easily. And thank you for watching this video. This problem was covered in the 17th June of 2022. So this is the solution for this problem, and thank you for watching this video. If you like the video, please hit the like button and please subscribe Programming Rush for more such videos. And thank you. See you in the next video.